Hello guys, welcome to In 5 Minutes. In current problem what they have given is 3 processes with their own burst time. They are assumed to arrive at 0 and we need to find average waiting period, turnaround time and the new one average response time. Now just to understand, the average response time is a time taken for a particular process to first get into communication or access and then to comment. So that's a response time completely to start and to commence. So let's go with it. For the initial problem, they have mentioned clearly that the sequence of first come first serve goes in this manner. I'm just making a Gantt chart for the same stuff, which consists first we will have P2, followed by we will have P3, and in the end we will be having P1. So let's go how things would work. So P2 will run 0 to 7, P3 would run for 3 more burst cycle, that means till 10, and from 10 P1 gets in and we will have total 29. So now we need to answer about wait period, turnaround and the response. I'm going one in a sequence. Let's see how we go through. The first thing, total turnaround time, or rather let's first try to finish total wait period. So total wait time, considering all arrived at 0, P2 waits for 0, P3 which arrived at 0 started at 7, and P10 which P1 which even arrived at 0 starts at 10. So the total time for waiting would be 17, and if we want average would be 17 by 3, which is 5.67. Second thing we need to calculate is a turnaround time, which will be addition of the wait period and the burst period. So total turnaround time, let's go with it. What we would do in this is for P2 wait period is 0 plus the burst time, that is 7. For P3 wait period was 7 and burst period is 3. For P1 the wait period was 10 and the burst period is 19. So total we have 46. Now getting the average turnaround time is simple, 46 by 3, which is 15.3. The last thing in the series which we are supposed to do is to talk about response time. So let's say total response time. Total response time is the wait period along with added with the time of completion. So in this case P2 had a 0 wait period and it completed at 7. P3 had to wait till 7 and next it got completed in 3. P1 started at 10 and got completed next 19 burst cycles. So it would be equivalent to turnaround time in this case. If we only consider response time, how they were response, it will be equivalent to the wait time. So it will be still 46 by 3, getting 15.3 as the final answer. So that's it for first come first serve. We're going for the last thing. The last thing which we have in this particular problem is a round robin system. In this case, round robin which we are trying to work with is with the quantum of 2 and we are supposed to handle it. So here sequence has not been given, so we are considering the sequence would be P1, P2, P3. If you want, you can also solve it by using the sequence of what first come first serve has given, that is P2, P3, P1. Slight changes would be there, but average would still come out to be the same stuff. So let's go with it. So considering P1, P2, P3 goes in the sequence, quantum of 2, let's go with it. First P1 goes from 0 to 2, left is 17. P2 goes in, left is again 5. P3 gets in, left is just 1. In the next round again P1 gets in, 8, left is 15. P2 gets in, left is 3. Finally P3 gets exhausted, giving only one cycle, making it 11, and now equation starts again. P1 again gets in and runs for 2 cycles, so that is 13. P2 about to get exhausted, getting further 15, and left is only 1. Again for the next round, P1 enters, left is 11, And finally exhausting P2 comes out to be 18, only one bus cycle in this case. And now the remaining stuff again and again done by P1 till it gets over. I'm just showing with a continuous line. If we want, we can show it with multiple blocks of 1. I'm just showing it directly. So that would be P1 at the end for the remaining blocks. So we have run cycle of 2, 2, 2, 2 and so on. So putting it together, we had cycle of 2, 2, 2, 2, 2, 1, 2, 2, 2, 1 and then further total cycle of. That's it. Thanks for watching this video.